Now we're going to move on to our presentation, which compares our technology to other solutions that are prevalent in the industry. And so the other technologies are robotic internal joint coating. You can use mechanical joints so to entirely avoid welding altogether, HDP pull-through liners, and bare pipe with corrosion allowance. So we'll review each of them one by one. So first off, our technology as compared to the robot. Robots have a number of quality issues, and one of them is the fact that they've got to paint over internal weld penetrations, which can be very challenging. I've spent a lot of time trying to get welds pinhole free inside of tanks and pipes in my career, and that's when you can actually see them. And I'm sure the robot, has access to them, and they've got the video cameras. But the problem is that not all weld penetrations are the same. And with their system, they really need to have very smooth weld penetrations. Otherwise, it's nearly impossible to get a pinhole free lining. So you've got a few photos there showing. Let me get the pointer going. You've got a few photos here of showing some jagged weld penetration. I'm sure it's not always that bad. You got some weld spatter. So any of those locations are going to be very difficult to get pinhole free. And even if you do get them pinhole free, it might be a pinhole location that would open up in the future. Our technology completely eliminates that issue. Our rings actually make welding easier and reduce the frequency of weld defects because they serve as backing rings. So one of another big problem with robots is it's a field applied coating. Anybody that's been in the coatings industry knows that it's much easier to apply coatings in a controlled environment, a shop setting, perform quality control. Whereas anytime you're in the field, there's unpredictabilities. Whenever there's a wide temperature fluctuation during a day, the cure times can be greatly affected. They will adjust the cure time of their paint based on the temperatures, but in the morning it can be cold, middle of the day it can be very hot, and the paint can actually have a tendency to sag down pipe walls as well, depending on temperatures of the steel. So whenever you can avoid applying coatings in the field, generally that's done in industry. And with the LPS system, obviously it completely eliminates that problem. When the rings and sleeves arrive in the job site, they're cured, quality controlled, and ready to go. So besides the quality concerns, one of the biggest issues with robots is the fact that the coating occurs after the welding is done. So the mainline crew will be welding along, moving down the line at pace of kilometer and a half a day. Robots simply can't keep up with that pace. So what ends up happening is tie-ins are left open. So they'll construct maybe 500 meters to a kilometer. They'll leave in sections. They'll leave the ends of the pipe open so that the robot can get in and out behind them, coating all of those welded joints. And because the robot can't coat as fast as people can weld, the robot crews end up getting far behind the mainline crew. So from the projects that we've heard from, primarily in Chile, but I'm sure it happens elsewhere, if the mainline crew is moving along at a fast pace, the tie-in crews and the robot crews will be left far behind, 20, 30, 40 kilometers we've heard, and often extend project timelines up to at least a few months, which just costs tens of millions of dollars. So the all-in cost of supporting those robot crews spread over tens of kilometers is far, far greater than just the actual cost of the robot coating itself. You have to have support crews, and it really increases complexity for the entire construction project and logistics. You can't completely bury all the pipe, until the robots are done. So that's one of the primary reasons several large contractors really refuse to use the robot. So mechanical joints really, again, avoid the problem altogether. A problem with mechanical bolted joints is they're a high cost, particularly for high pressure. Generally, they're not buried. Most places have rules against burying mechanical joints because they have a tendency to leak and you won't know when they leak. They just really aren't generally used for long distances. So for long distance, high pressure pipelines, it's really not so much of an option that you'll see out there. The HDP liner is really a fairly prevalent solution for pipe diameters that are smaller than 18-inch. When they first came out with the solution 20, 30 years ago, it really was a fairly good solution to the problem because there wasn't really anything much better. So they'll construct 500 meters, maybe a kilometer at a time. They'll pull the HDP liner through it, flange off each end, and then go on to the next section, as you see here in the photo. There's definitely some limitations. First off, larger diameters, the cost really gets up there when you get to larger diameter pipe. The pigging is a big issue. Pigs are known to get stuck in the pipelines, and several engineers don't recommend pigging just because they stress the liner. The liner is not bonded to the pipe wall, so as the pig goes through it, it stresses the liner and can cause it to sag, and that's one of the major issues. That is that over time, HDP liners are known to sag off the pipe walls. For at least for concentrate lines in Chile, most engineers have told me it's not a question of if they'll collapse, it's when. And generally that time frame is in that 15, 20-year time frame. And then when you have to repair it, we have to repair those sections that where the liner collapses and plugs the line. Those are also very complex. You don't just cut in and weld in a new section. You have to take out the entire liner for that entire kilometer and replace it, which takes up a lot of area, a lot of time. With the joint lock ring LP sleeve solution, first off, we're hoping there won't really need to be many repairs, but if there is, you just simply cut into the line and you can install rings or sleeves on each end of the existing pipe and drop in a new replacement section and weld away, and you're done. Bare pipe without any internal lining is actually one of the choices that have been made throughout the years, and I think primarily because there really has not been a good solution for welded joints with internally lined pipe. So you really have a short, unpredictable lifespan. They will generally build extra wall thickness in the steel to have a corrosion allowance. But the corrosion rate is often very unpredictable. It can corrode faster in one location than another. And it's generally, frowned upon. A couple pipelines are being built right now that we're aware of, where many engineers are really questioning why they went without an internal lining. Corrosion inhibitors can be used, but that's not really a perfect science. It's a complex science in itself. It generally does not cover the entire distance of a 100+ kilometer pipeline, and for a long-term solution, it's really not going to give you the longevity that you're looking for. So when it comes to our solution, where you simply insert these rings or sleeves in, do your weld. When the weld's done, that's it. You move on to the next one. You don't have to worry about it. It's really not that difficult to compare to some of these other solutions. Just some of the other ones are incumbent technologies, but we all know that the incumbent is not always the best solution. So